Welcome to Expert Structure. Today we have a new project about steel billboard structure. So I want to ask you first question about why we use the steel billboard. The steel billboard in the picture you see here about the steel billboard. If I ask you another question, you will find the answer by yourself. Why we use steel billboard advertising? So what does it mean for advertising? The purpose of your structure is to you advertise products, and for the structural engineer and for the designer, you have to focus about how to perform and how you can pass calculation of this type of structure. This is for the overall dimension of the structure. The ground to the column height is 12.5 meter and the board height is 5.5 meter and the board length is 12 meter. Now I want you to see about the 3D in SketchUp. You see here about the 3D view of the steel billboard in the SketchUp. You have length to length, and you have the board, and you have the column, and you have the frame to support and to connect the board each other, and you have another leading for the installer to move at the top. You see here about the steel billboard structure. And now we have to come back on our slide about the overall dimension and the apply load on the structure. We apply the load. Okay, you know about the surface and about the other load on the structure. We include it for the load, and for the horizontal load or lateral load, we apply the wind load. Wind we can apply in both directions, in X and in Y direction. This is for the direction of the load, E for the gravity load, and for another load is lateral load, side load. And for the type structure, we have to design, or we must to design the support. At the base is the fixed support. You cannot support you cannot design a pin support or other load support. Not stable. You have to make sure your structure is stable. Global stability is stable. Your structure is stable in global stability. It is very important before you start to design for the element for the member. You have to make sure your whole frame or your whole member or your whole structure is stable. So it's a very important condition. Boundary condition for the structure must be fixed support. And another load, we apply the imperfection in both direction, in X and Y direction. You see here our structure is perfectly straight. When you made in SketchUp, when you made it drawing in AutoCAD, perfectly straight. You can draw it as a line straight, but actually when you install it in the construction site, actually when this type of structure is come from the manufacturer or the industrial, the section is not perfectly straight. You can design it for the hot roll section, this section available, or you can design it for the flat welded each other. And so you must to take account of the global imperfection or the imperfection. Remember imperfection. You see here the imperfection in the X direction, another imperfection in the Y direction. So we have to include imperfection in our structure. So you can include it for the column and for the beam, but in the case I include for the critical member. It's a noise. It's a good concept. You must be include the imperfection in your member. especially for this type of structure, for the cantilever structure, you must be include the imperfection. And we continue to analysis. We use the p-data analysis. You can perform nonlinear analysis and check buckling and stability and design check. Okay, we will check about deflection. This structure we concern about deflection, and for the strength is no problem, because you use the larger element to resist bending, to resist shear, to resist the actual force. But after you design part the strength design, you have to check about the serviceability limits, that means your structure is suitable in deflection, not over deflect. Okay, you have to check it. This is pretty important. And for other phenomena like resonance or like vibration, we do not concern about it, because no human or no people lie at that board. So that board we use only for the advertising, so not affect on the human. If this structure affect on human, you have to check another criteria, okay, to make sure the human can be lie on live on that location. And for design, we design section, stick connection, and foundation. I want to mention you about one important about the eccentricity. When you model your structure, you have to focus about the reality of the structure. You see here about the above frame, and this one is supported member. I call it the supported beam, because it connect with a column, and this beam, and after that we have another beam at about this sub beam. So you see here is eccentricity here connect each other. Eccentricity will be produce more torsion in your beam. You have to make sure your beam can resist this requirement. You have to make sure your structure is model correct with the concept in the rear construction. When you do not make a sensitivity between the supported beam with the upper element, so the force will apply at the center, so no extra torsion develop in this section. So when we take eccentricity into account to calculating, to analyzing, so your member will be produce more torsion, so your member can be passed and fair according to your verification. In example, in the case if I design it in the eccentricity, okay, in this case if I design it when it's connect each other at the center of the beam, the section of the sub beam can be passed. But when I use the option with eccentricity, the same member and the same thickness is not passed, so you have to increase the thickness of the beam to support the above structure. So you have to make sure you can check about the critical member. You make sure your critical member is passed. No, we can make everything perfectly with the concept in construction, but you have to make in the important element to make sure that element can be resist the load. So in the case, the important element is the column and the supporting beam in both directions. So you have to make sure you check the option is very good. We will tell you, we will show you in the tutorial. We will show how I assign the eccentricity and what is different when you do not assign eccentricity, and what is different when you assign eccentricity. You can check. And finally we design for the footing. Okay, footing, you can design it for the footing or for the deposition ball pile. It depend on your land boundary, your soil boundary. If you have a large space, you can use footing, but in your space is near the boundary or other land, you have to use the pile footing. Pile foundation, ball pile foundation to resist this structure. And for the ball pile, you can check my previous tutorial about how to design rebar in ball pile. You can get more concept from that tutorial. It's a very good tutorial about how to design rebar in ball pile. So you have to collect more info. You have to collect more knowledge to be made sure you can design it with this condition. So in this one, you can design both in the shallow and deep foundation according to your site condition. Thank you for watching. We will continue to analyze it design in part 2. We will solve problem one by one by using model 3-fit optimization, design 3-fit optimization, and finally we got the result. Thank you for watching. Thank you.